चल गया ना। मुझे यही वाला लेआउट चलाना, ये वाला लेआउट चलाना। हेलो हेलो। हाँ सर। हाँ सर। ठीक है। अच्छा हाँ हाँ। अच्छा ठीक है सर, मैं आज ही करवा लूँगा। ठीक है। हाँ ठीक है सर, मैं करवा लूँगा। मैं ये बोल रहा था सर, ये दूसरा लेआउट पे चल जाएगा ना इसके अंदर? ठीक है सर। ठीक है सर, आई रिक्वेस्ट।
वो तो आ रहा 10 मिनट
कुछ नहीं है उसको, जैसे मैं दोबारा बंद कर दूँगा वो दोबारा लगा यूट्यूब पे थोड़ी देर। सर दोबारा हो गया वही, दोबारा वही एरर आ गया। अभी लाइव आ गया दोबारा।
ठीक है सर।
ठीक है, मैं यूट्यूब से देखते हैं आपको देख। ठीक है यूट्यूब
किसका नाम
पहला वाला कमाल आलबम का ना चेंज हो गया।
मुझे लिंक भेजोगे आप सबको शेयर करेंगे।
बोलने से क्या होता है? बोला तो मैं क्या कह रहा हूँ कॉल कर
Very good, carefully. All cameras. Very good. अच्छा, इसको चालू थोड़ी है, इसको हटा दो।
इसने एक्सेप्ट किया। अब तो किसी की अभी नहीं कर सकते। क्या जल्दी भेजना बंद देना
पता चले इसकी ये खुद की आप ही डराती हो।
थप्पड़ मार दे, मैं तेरी जगह होती ना थप्पड़ मार देता।
अब इसे मैं तो ना सकता, इसे बेइज्जती करता हूँ। मेरा दोस्त मेरे साथ क्या होता देख रहा है?
I told her I love you.
इसको लिंक कर सकते हैं मेरे साथ व्हाट्सएप शेयर इसका लिंक
पीडीएफ का
नहीं जो पीडीएफ यूट्यूब
हाँ
अब ये
करो ना
ये वहीं क्यों बैठे उसको बोल रहा है समय कर रही
डी ड्राइव से ढूंढ लेना ना, 2 फोल्डर उसमें सेव है। डी ड्राइव में 2 फोल्डर है, जैसे एक में
ठीक है चलेगा देखते हैं क्या होगा इसमें तुम्हारा नाम ही तो आ रहा है ना इसके अलावा क्या होगा
और कोई नहीं
मेरे को भेजो इसका लिंक भेजो
भेज दिया सर व्हाट्सएप पे
अभी लाइव थोड़ी किया इसको चालू
अभी चालू है
लाइव नहीं अभी नहीं करो थोड़ा मैं कहूँ तभी करो
ईमेल करूँ
नहीं इसको व्हाट्सएप देखता हूँ
तभी तो बोला ना मैं, तू ले
Yeah, now we can start. You can open your notebook, keep your everything ready, laptop, everything. This slide, there is a little correction is there in this side. This is only half here. This is by mistake has been drawn. So. This free vibration curve is there. is a displacement. This is, and this is 3 mm. Take it. Oh, no, ये नहीं. First problem, last problem, last. नहीं नहीं ये. हाँ yes yes. इसको जाओ नीचे जाओ नीचे. हाँ yes. इसका force diagram. अच्छा force diagram वहाँ आ गया. ठीक है. थोड़ा नीचे लो. You can see it. Yes yes. हाँ. You can see the problem. Yes. Period कितना है? 0.5 second था कितना था? Okay, so this is little corrections in the whatever is shown in this file transparency. Just read the question. Now the whatever you read it, studied it so far, force-based concept. Now this is some sort of a realistic example in which you have this is a plan is there. There are 4 columns, and 4 columns. This here is a machine is anchored, and machine is high pressure 5,000 kg weight is there. The RPM of machine is 750 RPM, and the machine has a eccentric mass of 30 kg, and eccentricity is 100 millimeters. Now this was when you put the machine into operations, machine vibrates. Realistic example is you have seen, you read the newspaper also, the newspaper which is printed is this kind of machine is there. So machine in the, say 1 hour they more than 5 lakhs newspaper they print it very fast. So entire floor vibrates. So most of the time they keep this such type of machine in the basement area. But many places the machine is mounted on the upper floors also. So then design becomes very important. So all vibration transfer. So this is a realistic example. And for the satisfactory performance, that is performance limit, we are going to fix it is this displacement is not to exceed 0.1 millimeter. Because what, see, if it exceed it, newspaper you say this has a printing, it's very difficult to read it. So the platform should not exceed the vibration. And all the remaining data is given. Concrete quality is here is M35. Density of concrete is given, so you need not to refer any code, anything. And column size is given 600 is to begin with. Now your task is to calculate the bending moment in the column which generate because of this. Now force which is generating, the vibration is coming because of this eccentric mass. Had it been the no eccentric mass, so every machine has a eccentric mass. That is not in our. And this manufacturer supplies it. So you need not to invent any new things in this one. Whosoever machine manufacturer, he will always give specification. This much is eccentric mass, this much is eccentricity, and how much weight of the machine. These 3 information specification of machines is there. So this is given. So RPM machine. Now your task is to calculate the bending moment in the column. So this you have seen it. Can take it up little. Just read. So, lower portion and the graph is given, that is a response spectrum is given. This you can see. The column size I think I made 400. Let's check. I have some changes. Shall I keep the mouse and keep it? I can use this one. Yeah. Okay. Can I use from here, no? Okay, that's good. That's fantastic. Okay, that's very good. So, the right now column size is 400 by 400. This slab thickness, that is the roof of, let's consider you are sitting in this room. This is, slab is 300 millimeters. And mounted on these columns. Column size is 400 by 400 millimeter. The height of each column is 3.3 meter. There are 4 columns. So I have not made 3D view. This plan and section is there. okay? And center to center column distance is given is 3 meters, and the offset is 1 millimeter on each side, 1 meter on each side. And this machine is mounted, so this is centrically placed, okay? So now we have to do the calculation. Now, because of this eccentric mass, you already been given the information, the equation is given. So how much is force which develop is given, that is PT, the time dependent formula is MB, that is eccentric mass, E is eccentricity, omega is the frequency of forcing function, and sin, that is this is sinusoidal force. How sinusoidal force is come? This is mechanics, simple mechanics is there. If you want, don't go too much on that side. Just for your understanding as a student, it is like this one. So this is how the mass moves, this one. So this is E, this is centering mass, and this is rotating. As a result of this, this is your system is there. This is your system. Okay, so column is there, you have a stiffness. So column is there, and every material has its own damping, so you can model it, so damping is there. So this is a mechanical model of the scene, and this is moving, okay? And as a result of this one is generate a force. And the force is given, so you need not to remember the equation, and sin omega. This you can derive it, this equation you can derive, but at this stage you need not to do it, it is given to you. So can you begin with, start with, how you go about? Just note, I think it's 2 minutes, and then we'll do it. You have a background of dynamics also, so you can, I think you should be able to pick up this. You can do independently, you can do group, but if you do independently, will you try to understand? So it is not an exam also, so you can easily do it. Just think 2 minutes and then let me know how you proceed it. And your calculation should be neat and clean. Don't do absurd way. You are engineer, so you have to produce a design which is neat and clean, absolutely neat and clean. Your calculation should be perfect, very systematic. See, what is the target for this? What is the target parameter? Bending moment. Bending moment you have to calculate, okay? Mechanical model already shown to you, so some idea must you have got it. Okay, the stiffness is vertical stiffness column. Okay, so bending moment. What is the need? How it will deflect it? The vertical component of this eccentric mass will create a vibration in the system. Horizontal component will cancel out. Okay. So that part also need not to think, just is a mechanics how it works. That's all. But you have straightway given the equation, so you can calculate the eccentric mass. Okay. First thing is that omega square. Omega is what? Forcing frequency. Forcing frequency. Okay. And RPM of machine is given. So you can calculate omega. Just do that. How do you calculate? From RPM, how do you calculate omega? Just loudly. Anybody else? RPM divided by 60. Yes, that will give your frequency. Just do calculate. You got it? First. question? Oh. Okay. First thing, you calculate the forcing frequency, omega. Now, what is your target is what you have to calculate ultimately is bending moment. What is the equation bending moment you need is? Yes, anybody? To calculate bending moment, what is need? Just think, that's what I said, you just think, don't do arbitrary things, don't do something on piece of paper, just think clear, very crystal, as if you are now designer, how to do it, you have to do it, very systematic. First thing I said, you need to frequency, RPMs you calculate frequency, very straightforward, the 9th standard you can do it very easily. So RPM divided by 60, you get a frequency in per second, hertz, okay? Now you convert into the radian. So what you need to do is 2 pi. Multiply by 2 pi, you get the radian per second. Okay? Okay. So that is a forcing frequency, so omega square. Now eccentricity is given 100 millimeters. Eccentric mass is given. Now you need a maximum force because your equation is okay, you have done it. And this you can write this, if sinusoidal force is there. Okay, and now this force is given. So this is the amplitude part. So how much force you get? If you go, this is kg, millimeter, radian per second, you get force in newtons. Okay, so you can do it quickly. So have you reached to calculate how much that this force is PT? Okay. So force is come, now you can calculate P0. Then P0. Now ultimately what you need is transmissibility. Transmissibility will come in the picture when force is transferred from either from ground to structure or structure to the ground. Now here is no transmissibility. Neither force we are taking to the ground. We are not designing a foundation. Okay. Or nor oscillation is coming from the ground. So that is not there. Okay. to this one you have gone? P0 you have calculated. Okay. Okay, guys, I give an idea hint to you is that you need a K. Dimension of column is given to you. Okay, K is how much? Yes, very good. Okay, so height of column is given to you. How much is? Yes. Now FCK is given, concrete grade is given, M35. Okay, so now you calculate E substitute, so you get a E. Okay, now to begin with, I is given, the column is 400 by 400, okay?
600. It's 600 by 600.
No. This is when revision comes. Initially you are given 400. Okay. When revision comes, if this criteria is not satisfied upon 1 millimeter, then you revise the things. Revision comes, that means if revision at all, if you require, you go for revision. In that case, the column size maximum I specified. That means you're not doing random things. Otherwise, each one will do separately. So many answers will come. So you have to keep in the bandwidth. So that is the maximum range is given. But still, I will give some more things to that. Your dimension, you have to be very clear about. So this is I is there. L is given. So L you take it is what is height of the column is there. Okay. So now can you calculate this K quickly? Got it? You K you reach?
Yes.
Okay, very good. Now you once you K you reach it, now you can calculate natural frequency. Now task is to calculate M. Now M will constitute what? The machine weight. Machine weight is there. Okay. Now, as yes, Dave, this Arijit mentioned earlier also, the column weight is there, and weight of this mass of this one. So density of concrete is not given, thickness is given, size of platform is given. So you can calculate how much weight of this one. So this weight is given to you. This you can calculate it. Now columns. How many columns are there? 4 columns. Now what he has done is, if you can recall it, what doing the similar, not exactly, but typical problem where what we did is, he taken half of the mass of the column to the top. So that is why standard practice of this one is, why you take half? Anybody idea? No. Okay, we'll talk somewhere. But just to begin with, that's how we do is that take calculate. So weight is calculated, density of concrete is known to you, size is known to you. So you can calculate a weight of this one and take half of this mass to here, half of this mass to here. Okay, so there are 4 columns. So calculate of one mass of one column, multiply by 4, and take a half above. So that is called lumping of the mass. Lumping mass, you did it? Lumping mass? Okay, so that is lumping basically. So you lump the half of the mass at the top, half of mass at the bottom. So bottom is at the foundation. So half of mass has gone to floor. So M, this constitute the mass of this this one plus mass of this is already specified 5000 kg. So you have dimensionally you have to be very correct in this kg, hai na? And mass of half of the mass of this entire column system at the top. So just and do all separately. Mass of the printing machine, mass of the roof, and mass of the column. All three calculation when you do separately, M1, M2, M3, and then sum it, because you need somewhere some specific data also. So you calculate M. Make a little fast calculation so you understand. You calculate? Okay. We will match afterwards because many people are getting different answer. So here a first target is you understand the procedure, how to do it. So natural frequency calculate it. Okay. Now you calculate the frequency ratio, which you have done it. This is a dynamic amplifications, you take it. So xi is how much? Concrete structure 5%. State recognition. Steel 2%, concrete 5%. That is given in the code. So you have calculated beta, you know the xi, P0 you know, K you have calculated, put the dimension appropriately and calculate the delta. Calculated delta? Careful while putting the dimension, it should be consistent. Dimension should be consistent. Mass should be in kg. You have to be very careful. That's what it says. You dimensionally you have to be very careful while doing it. So this equation which we use is PT is MBE omega square sin. So you have to be very careful. Mass should be in kg. E if you're taking mm, then omega is radian per second, so force you get in Newton. Okay? Dimension. When you calculate K and I, dimensionally you have to be very consistent. E you calculating, so it is Newton per mm square. Okay, FCK is 35. So accordingly, I you substitute. Just sake of convenience, I not wrote 400 mm, just 0.4 meter per. So dimensionally, you have to save the space, I did it like this. But you have to be careful. Then calculate omega n, so it is radian per second. Accordingly, you take the frequency ratio and substitute here.
ठीक है कुछ नहीं बस 25 को 25
How many people have reached to the answer? So you are doing it group wise now. Then I will ask each one to separately speak out the result, because final result should be matched with all.
ओमेगा इन 177 है मीटर में कर सकते
Dimensionally, you have to be very consistent in the calculation. See how much dimension you have taken it? 5 by 5. Perfect. See, density of concrete is given. वापस इसको करें, मैं कर सकता हूँ उसको. See, density of concrete is given, है ना? So you have to be clear. 5 by 5. This is 0.3 mm thickness. Density multiplied, you get a mass of this roof. Plus 5,000, you add it. This, okay? Plus 4 columns. 4 into K, 3, so 400 by 400, that is 0.4 by 0.4 into 3.3 into 25. So that is weight of total column. Make it half and tuck it lump at the top.
मैं क्या निकल गया यार, लेकिन मेरे पास अभी 177 आ रहा है, गलत है।
So how much maximum deformation?
नहीं 177.4 आ रहा है।
Kita? How much? How much this values? Got it? How much? Speak. I need final answer.
अरे 56.2 साल
Everybody will speak answer. Final answer. 0.932. Okay, who has got this answer? What about you? You have final reach? Not yet. What about you? No. Anybody has reached to answer final answer? If damping of concrete is not given any time, you can assume it's 5%. If it is steel, you can assume it's of 2%. How much? Loudly. 1.051 meter. The second answer is 1.05 mm. Okay. What about any other answer? Here, 0.23. So answer has changed.
2.43
Point
923
923. Okay, doesn't matter. This is not going to influence much.
multiply कर दिया 0.923
So this xi you substitute, it becomes 0.05 here. Beta as usual. So you calculate.
0.442 is 390
Instead of 0.923, 0.233.
0.233. So this is your third answer.
No, this is the second.
0.22.
0.233. Double three.
Okay. But at least you calculated. That's appreciable. Let it think. Who else is?
इसको मत मिटाना, ये कैलकुलेशन इसको मिटाना है। ऐसे मेरा हो जाएगा बैक।
So tomorrow post lunch we have your assessment then. So we give some set of problems, you need to solve it. So you can have a books, notes, everything open. All study materials so far taught to you till now, you can bring it. So anybody has got new answer? Or we freeze it here?
हमारा आई मीटर
No answer from this side, quickly. From this side, one to answer.
सर 0.0233 आ रहा है।
Point,
सेम 0.0233
point zero. This is mm or somewhat?
हाँ सर अभी
So that's what we are confirming.
So this is not confirm answer. Okay. Got it? You answer? 0.49. But at least this appearing from answer, you are getting everybody get difference. The variation is very large. So you should come close. But at least this appears that this is not going to safe. This is not going to sustain it. So limit is 0.1 only. This should be less than 0.1 mm. Because the range which has been given is 0.1 mm. So, any case, this platform's vibration should not exceed by 0.1 mm.
So 0.233.
0.2. This first answer. Anybody else? Do it little fast so that we can attempt one more program at least before break for lunch. Not much difficult question, eh? All very simple. You have to crunch the data only. Everything solution I. 1, 2, 3, 3 final. Okay. Yes. 0.129. Difference is there. Yeah? Finally? Okay. Anybody one answer, then we one by one will go and check it. Where is the difference? Anybody from this side, one answer. Quickly.
वो सही वैल्यू है
Okay, let's come here before. Okay, how much this one is? Speak loudly.
78.5.
This one?
78.5.
This one?
Yes.
78 point? Yes, from this side? Clear?
Yes.
Everybody has 78.5? Okay. This is radian per second. है ना? Okay, great. Now, what about this mass? Let's come to the mass.
26390.
264.
Let's do very systematic. Otherwise, everybody will get a different answer. Now, this M consists of make it separate. Slave, how much it is?
18750.
18750 kg. Huh? This is clear for everybody has this answer?
Yes.
Okay. Printing, this is given. So 5,000, you need not to do anything. Plus column. 2640. Everybody's answer is this?
Yes.
Column? Okay. So that's great. So the final is how much? 26390. Everybody has got this answer? Okay, great. Now come here. E is how much? 29580.4. You got it? Everybody has this answer? Hmm? Okay, great. Now I. 1.12, this you keep it in dimension, you should be keeping consider. I 0.4, so writing is easy, I did it, but you can do it in mm. So how much this I is, let me know. In mm. Yes, let me speak. 0.0213
meter to the power 4.
So you convert into the mm. How much? 10 to power? 10? Simple. How much?
10 to the power 9.
Everybody's answer? All? Now we substitute. This is 3.3 meter. Okay. E is known to you, I is known to you. This is K. Okay. Now you have 4 columns. Okay. Multiply it. So how much K is? 8, 4, 2, 8. Yes. 10 to the power 3. So Newton meter. Hai na? Everybody's answer? Okay, great. So now you come here. K and M. So you substitute here.
56.5.
Radian per second. Okay? Great. So now beta is there. So this is 78.5 divided by 56 point something. So beta comes out how much? 1.38. This is ratio.
1.39 up.
Is it? Okay. Let it be 39. Now we substitute here. So this P0 is known to you, K known to you, this you substitute here and take a square root of this one. 0.233, everybody? So remaining 2 I can remove? Okay. So what happens finally? Your limit is 0.1 mm. So maximum deformations can take place is 0.1 mm. Okay, but you are getting is 0.23. So what will happen? Is unsafe. Okay? Yes. So that means this platform is not going to survive. Means what? You get a printing which will be hazy. Because limit is 0.1, so you get a hazy printing. So that means you have to revise it. What to do is, you have to bring to the limit to 0.1. That is your target. So in order to have this platform should function for which it has been. So what to do is, what is the remedial solution? What is in your hand? So you cannot change this platform, this roof you cannot, it has to be. Only thing in your hand is to column. That is why in the question itself was written that you can maximum can have it is 600 by 600. Okay? So let's put. So don't go to, so maximum what you will doing it. So do it very systematic. You start from here. This is known to you. Okay? This is forcing frequency. Machine is specified, so you cannot change it. Now your hand is that you can change this one, natural frequency, which depends upon the K and M. Okay? M is largely fixed because maximum, that is why I wrote you mass, you write separately. So if you know the how much mass of the column in percentage of total, you see how much contribution is there. So you can, from there you can make out. So largely contribution is from the stiffness. Okay, so and you, as you know, this is, so this is largely fixed. This you can change it, which is in your hand. Okay, so if you do it, rewrite. This is a natural frequency. I write revise. Now what you do is here, this beta earlier is coming, how much, what ratio you are getting? 1.3, 1.4 approximately. If you look at this spectrum, okay, this is 1. This ratio is 1. The frequency ratio is 1. Okay. Now this start almost close to 1. Right now you are at 1.4, right? So you are somewhere here. The frequency is 1.39. So you are on the right hand side. Okay. If you from here you move towards the left side, if you look at this, your maximum can reach it is 1. Okay. So one iteration possible is, let's little go away from this side. Okay. And so come somewhere here. So you can assume it certain new value. So let's assume it is 1.6. Assume it. Why you assuming? This is the reason. Look at the plot. So assume it. So this is iterative process. So you get this new value of omega n. Okay. So new value, so this you substitute, mass is fixed almost, not very. So you get a new value of stiffness. Okay. This stiffness is consist of what? 1.12 48 EI upon LQ. E is fixed, L is fixed. So what is it? I will change. So get new value of I. And it's a square column. And so square column, so you can know 1.12 BDQ. So if B and D are same, you can do, here you can play and calculate the new value of B, how much. So that will give the, what is the new size of the column you need to have. Okay, this. But this is a very crude way of doing the things. Best way is, as an engineer, sir, what you have to do, you write few lines of the program in an Excel sheet or somewhere and put the value, because this is the upper limit has been fixed. So you put the dimension B and D differently and try to match with the new value of I. So let's start from 250 and this other dimension differently and write Excel sheet. I have all those, I think I have more than 1,000 results are there wearing the B and D. I will show later. So you just make it, yeah, and then see how much. That will be interesting part. Yeah? So write a few line of Excel program and then change the B and D and come out with, that is the most optimized design of the column you get it. But see that the dimension should not go below 300 in each case, at least. So other upper dimension you can have. So that is a broad idea. So you can play with those two numbers. So that is why I said, so what we do normally is take some ratio. That is better way of doing it. And then iterate it. So that is handling wise it will be easy. Okay. So will you calculate the answer? No. So can we attempt one more problem? Yeah, we can. Okay. So let's say smaller problem which we can do it out of these 4 problems, which is a smaller way which we can do quickly. Yes, let's do this. Now, how early you want your lunch depends upon how fast you do it. Okay? So this is just connected with the last problem, so that it's easy to move it. A printing machine, same way, it is mounted on this platform, and the unbalanced mass is 300 kg. Now we increase it, and eccentricity is 100 millimeter as usual. The machine is designed to operate at 900 RPM, so very fast machine is there. The material properties of platform. Now this is an old platform which is existing and you don't know anything about this platform. No design drawing is available to you. Nothing is not done. So what we do is, we have conducted a hammer test, or that is what is there. And so there is a way of doing it, just pull it. So what that is, static displacement of 5, a lateral force of 40 kilonewton is required. That means 45 kilonewton means how many tons?
4.5.
So that much you pull it, so this platform will pull by this, so you get some information, okay? So due to non-availability of precise equipment, only selected information can be obtained from the vibration curve. So some of the things which you want, still you can use from the same curve, which we have used, this curve. Same curve. So curve is same. This is only half. By printing, pulling, this has happened, but this is only half curve, okay? So calculate the steady state. So the answer is very simple here. Only you have to calculate it. This is a steady state response, because in there are two steady state and transient. There are two solutions are there. So transient is will die out after some time. This remains, which is you need to handle its situation. So this you have to calculate. So can you do it? It's very fast. It's hardly 7-8 step solutions. How you go about this one? Can you tell me quickly? Don't do jumbling here and here and there. Very straightforward.
E0 is multiplied.
Yeah, that is there. Yes.
Column dimension.
Nothing is known. That's what written. You don't know anything. That's what written. Since material property of platform are not known, so free vibration, and whatever information you catch is through the diagram. That is information. So what you get it? See, you come here. I just one information. This is half only, so this is by mistake. I pulling this. I did it. So what you get it? See, the peak is going down. That means damping is there. Okay, damping is. And this is how many cycles? You start from here. This is 1 cycle. This is up cycle. The 1.5 cycles. Okay, and here is a damping. Okay, and if you go damping, it goes like this. Straight curve. Huh? That is not. So nothing is known to you. So what you need to do is to begin with. You can assume it. Because in cushion itself it's written. So material property of platform are not known precisely. No concrete grade, nothing is there. It is an old existing platform. The building is there. And why I took this approximation? Because xi is 5%. If you take 5%, square root of 5.05, square it 0.0025. 1 minus 0.0025 is how much? Very small. That is why this assumption is valid. Okay? So now if this is valid, then the cycle to cycle, 1.5 cycle, the period is 0.5. So divide by this, so you get how much? See this 1.5 cycle, 0.5. So that is what I said it. No one would precise, only selected information can be drawn from the response curve which is given. So how much it is? 0.33. Okay. So you calculate the natural frequency. Calculate. 18 point? Now I will jump little higher quickly. Is that if you can remember logarithmic decrement which you have done it. So either you can derive it or you can remember it. Okay. So now you come here. First is 4.5, then this come 3. It's 4.5 by 3. So use 4.5 by 3 here. So let me know how much it is. Yeah, quickly do it. Point. Percentage or absolute value? Okay, so you reach your damping.
obviously होगा ना obviously होगा ना
This is a natural log, है ना? Not 10 base, it is natural log. 0.028.
log base 10 लेके तो natural log से तो वही तो लिखा था 0.065
You take it, calculator is using, use IN. Okay.
सर अगर natural log लेंगे तो 0.0645 आए natural log लेके 0.0645
That's what you can do. Yeah, whatever. Now, natural frequency is, you know it is. Okay. Now, M you know it. M you know it. Or you, K you know it. What do you know? K you know it. K is how much?
9,000 Newton per mm.
9,000 Newton per mm.
So that is, K is how much? P by delta, na? So force is given and displacement is given. That is what the information you can extract is 5 mm, na? So K is known to you. K you substitute here. So you will get, this is known to you. So this mass you will get it. So you know the existing platform, how much mass is there. So you need not to go and calculate dimension, everything, nothing is required. Okay? Now RPM of machine is given. So you can calculate. Okay? Once this is known to you, this you can calculate. Then once you calculate this one, you substitute, that's it. Simple.
फाइव आ रहा है ना हाँ मेरा भी गामा बीटा
You are a very high value. 5 means you are almost downside, which happens very rarely.
delta is 0.208
Point
mm
How much?
0.208
0.014.
Oh, different answer.
08
0.208. Correct, na?
yes sir
Anybody else? What? Everybody got same answer or different? No, they are very fast. Everything is done. You have to crunch data only simply. What same answer? Okay. Same? Okay, good. So now you can stop here. So how interesting is? Let me know. You got something new? Feeling something? Or it's a regular one? Some exciting? Okay, good. Okay. That's the purpose itself. So one more problem is there related to this one, which I will giving you when you go home, you take one problem. But when you come back, you will do some more things. Okay? Thank you. So you have your good lunch and come back quickly. So 2:15 we'll start class again. Okay? And after post lunch, we will show you, Shashi is here, how the pushover car actually is drawn. So he will show you, and you should have your laptop machine. SAP is there. Whatever SAP I shown in the morning, those you can really develop those cars. Okay.
नहीं उसको नहीं फिर मैं आगे पूछूंगा वो